Hello, good morning and good evening, wherever you are. Um, Welcome to this talk. This is about deep application security, observability, and runtime protection. As you all know, Avocado has been focused on building some cool technologies for the enterprises and applications and trying to build the next step in application security. Before we get started, I just want to give you a perspective of why Avocado. Avocado is unique in the sense that it is an application security technology that works within the context of the application. There are many technologies available in the enterprise in the market today. Many of them focused on firewalls, protecting internal assets and applications. There are network segmentation technologies available. There are host-based controls available for monitoring and so forth. But with Avocado, we are embedded deep into the application and we are looking at processes, ports, APIs, and any data exchanging happening between those APIs. This is what makes us different. In fact, Forrester called us out as a way to ring fence process level application at the process level and providing this extra zero trust granularity. This kind of was very unique capability for Avocado. By embedding ourselves, what can we do? We are able to provide real-time app security. We are able to provide observability of the unknowns. We are able to prevent exploitation of zero-day attacks. And using our zero trust technology, we provide trust between processes communicating with each other. The other key enabler is to make this all available for DevSecOps. Why do we do it? Well, we are looking at mostly from an application's development lifecycle, wherein developers are shifting left and the operations are shifting right. So we want to be able to address both these problems by shifting left as well as shifting right. In that context, what we have done is built out two products. One is called Avocado Reveal, and the other is called Avocado Protect. Obviously, the audience for each of these applications are developers and operational entities, right? So with Avocado Reveal, we are able to look at all the things that are happening from within the application and providing this deepest level of security observability, wherein we are able to discover and diagnose various applications and processes belonging to applications, any API communications that are happening at this process to process level, and also any communication that is happening, we're able to look at it and provide insights into those communication data. We also provide a way to generate architectural models, which are very essential for developers to understand the runtime aspects of their application and the application fanouts. And this is very unique from way Avocado's approach the problem. And this observability lends itself to many use cases, such as threat modeling, architectural governance, data governance. All these use cases get enabled because of the way we are looking at those applications and processes and collecting information. Additionally, we can also enforce policies, data policies on these application processes as they are communicating and be able to identify OWASP top 10 kind of vulnerabilities, be it SQL injection, be it remote code execution, or even cross-site scripting, etc. Those kinds of threats can also be detected. We also kind of help monitor, allow the users to create custom rules which help them monitor PCI DSS, GDPR requirements, etc. As we move the developer through the development lifecycle and as they observe their applications, we are able to mitigate all of them and using the Avocado Protect without having to do any changes to the code. The beauty of the Avocado solution is it's purely runtime, and no application developers need to make changes to their application or code or instrument their code for Avocado to work. Okay. The way Avocado operates, because it is running inside the application or running close to the application, we are agnostic to application architectures. So the application could be running in a bare metal server, could be running in a VM, or could be running in a Docker container or a Kubernetes container. It does not matter. we are able to bring in both the capabilities of Reveal and Protect into that application. And from a Protect perspective, our main focus is about stopping east-west lateral threats. What does this mean to you? Well, we all know what happens today, right? A new zero-day vulnerability gets released, people scramble to go fix it. And particularly take, for example, Log4j, which is the essence of this talk, and the demos that I show will be around the Log4j. How these zero-day vulnerabilities get exploited. And the key challenge is, without having understood how these zero-day attacks happen, it is difficult to protect them. Many times, security researchers spend a lot of time understanding the zero-day vulnerability, documenting it, and then publishing it. By the time has run out for many application developers and application teams, wherein they have to go and remediate their applications, upgrade their applications, and so forth. We provide that capability at runtime without having to make any changes to the application. And part of the demo, I'll be also showing you how this zero trust works, so you get a feel for the whole platform in terms of both the observability and the protection. Just to give you a little insight into how this thing happens. So the Avocado architecture is composed of basically two components. One is called the security orchestrator, which is the management console, which is the central place where you would go and look at all your observability capabilities, as well as security controls for your application. The Avocado Security Orchestrator also provides a dashboard, which I'll kind of walk you through when I show the demo, and be able to show you all the things that you can do from an orchestrator perspective. The Avocado Security plugin is the key element to how we manage application or deliver application security into the application itself. The security plugin gets deployed into the application environment, and then there are various methods of activating it, enabling it. Once it's deployed and the applications are restarted, we start collecting telemetry for observability and also use the same information for any protection aspects. Being the way we operate and the level at which we operate, irrespective of what kind of a programming language that's out there, we kind of try bring in these security capabilities. So your applications could be Java applications, Node.js, Python, a variety of this, even database applications like Postgres, MySQL. All of them work seamlessly with the Avocado plugins. Now, I want to flip and provide you some context about how the Log4j exploit happened. And many of you are probably aware of it, but I just want to kind of lay out the whole flow so you better understand from a demo perspective how this is working in the context of Avocado. Okay. Typically, the Log4j exploit happens through a vulnerable Java application, which is using a vulnerable Log4j library, wherein you deploy your application gets exploited through a GNDI execution. And the GNDI execution could happen through an injection attack or any other side applications trying to call APIs and injecting this into the API itself. Imagine a hacker sitting there trying to inject the GNDI attack into your Java application. And the hacker typically has a malicious LDAP server listening out for any callbacks because the GNDI indicates or specifies where the exploited Java application needs to call back. In this case, let's assume that you have a hackq.com, which is where the hacker is running his malicious LDAP server and attacking from there. And the attack goes through by injecting the command, and the callback happens from the Java application to the attacker's malicious server. Once the attacker's malicious server is contacted, the attacker's malicious server injects a malicious Java code back into the Java application into the runtime. This exploit then runs inside the context of that Java application and makes a remote shell call out through the attacker. And now at this point of time, all bets are off. The attacker is inside your application environment. The attacker is able to go in and start exploiting your application. Now, imagine how Avocado would protect some kind of thing. This is a very difficult to predict attack because nobody knows how the application flows are happening and where the application is calling out, and it's all happening at the instant of at the same instant and hard to detect and protect. Okay. Now with Avocado, let's assume that we have Avocado deployed into the Java application. You see those green circles indicative that the plugins have been deployed into that environment where the application is running, and the plugins are enabled. And not only are they protecting it, but they are also kind of observing all the flows that are going in and out of the application. Now, as an attacker injects the JNDI like you saw before, immediately Avocado's data policies filtering capability kicks in and blocks the attacker. Now you might be all wondering, hey, this is a zero-day attack. I may not have a policy or a filter policy available for me because I don't know what the attack is. So assume that the attack is not there and the policy is not there. Sorry, the policy is not there and the attacker continues. Now, the next thing is where Avocado brings in key zero trust capabilities. So it immediately knows that the Java application is being exploited, and there is an outbound communication happening from the Java application. Immediately, the Avocado zero trust kicks in, now identifies this, there's an untrusted communication happening outside, it immediately blocks it. Now assume that even with that untrusted communication, due to some misconfiguration, and possibly somebody had allowed an outbound communication to go to an LDAP server. So that communication may be a valid communication. Now in that case, even if the zero trust policies bypassed by a exception, still the Avocado prevents that threat by blocking that inbound communication that's happening, as well as the outbound communication that's happening to the remote shell. In this way, you see at every stage in the kill chain, Avocado is looking at and observing all the application flows, all the communications, and not only is able to capture the information regarding the attacker or regarding where the attack came from, but is also able to block it in real time. This is the power of Avocado. This is what you will see part of the demo. So hold your seats. Okay. Now, as part of the demo, I'm going to walk you through a couple of things. One is the application discovery and architecture modeling. You'll also be able to see the interdependencies of processes across all tiers. You'll also see how these information is captured in APIs and stored procedures also identified, and any vulnerabilities. In the protect phase of the application, you'll be able to see how the automatic zero trust controls come into picture at the process level, how it's protected. We'll also be able to detect any OWASP top 10 threats per segment. We'll also prevent lateral movement of threats. This is a very important aspect of Avocado. Now, before I jump into the demo, let me just switch the screens. And here you see the Avocado Orchestrator. As you see, the Avocado Orchestrator is the dashboard and provides the single management dashboard for all the security functions of your applications. As you see on the left side, the dashboard, you have a quick set of widgets that you can manage policies, you can manage your environment, you can also download reports and also provision users. And also you'll be able to see the quick summary of all the things that are happening across your application ecosystem. If you notice here, I have a collection of applications running in. Some of them are simple Java applications. In this case, it's a MySQL database running with some vulnerabilities identified. There's also a little more richer environment wherein things like Ruby, Postgres, Redis server, HTTP, all these are part of this application ecosystem. And Avocado is able to look at, intercept it, and protect all these kinds of applications too. Also, what I have done here, part of the demos, have two applications. It's called the finance portal. One is in the reveal mode. As I said, the only reveal aspect of the product is enabled. And the other thing is the protect mode of the application is enabled on the same application in another set of containers. So if you notice here, this application container is running in a protect mode, whereas the other applications here in the unprotected containers are running in the reveal mode. Okay. Now, since all these applications are up and running, and also the containers are active, and that all the information collected by the plugins are being sent to the orchestrator is able to visualize that. Now, let me take you to the actual application itself. So on the right side of my screen, you see the application. This is the application I was talking about, which has the Log4j vulnerability. In fact, the Log4j vulnerability can be exploited by typing in the Log4j injection into the username section of this application. The same application here is in, this one is in reveal mode, and the second tab here is in protect mode. Okay, so if you notice at the bottom of the screen, I have the attacker console. So I am the attacker. I have spun up a malicious LDAP, which is listening on port 1389 in an attacker environment, and then also the attacker provides in information about how to inject into that Log4j vulnerable application. So in this case, this is the JNDI string that you'll see. I will take to inject into the unprotected application, and then you'll see how the whole attack proceeds. Okay. So I'm going to inject into that application, and immediately you see the attacker gets the LDAP is called. The LDAP then injects the exploit class back into the Java application, and that exploit class does a reverse shell connection back into the attacker. Now the attacker at the bottom is able to take full control of your application environment and start moving laterally and exploiting all the assets and so forth. So in this case, since I'm inside, I'm able to go in and do a lot of things. I can see who am I? Now I have root privileges. I can do a lot of things in this environment. I can even go ahead and download additional software into this and malware into this environment and start exploiting and going. So I can even go in and say, install wget for that matter. So I can say apt you see I'm able to go in and do a lot of damage into the environment, downloading new things. Now that I have wget downloaded, I can go ahead and say, go to a hacker site or go to a malicious site and download new things. So I'll just go to google.com and download some stuff. So you see I'm able to go in easily, move laterally, download new things, and exploit the whole environment. This is the nature in which how these zero-day attacks come in, how one can easily exploit these applications. Now what I'm going to do is quickly abort this, and I'm going to switch to the right side of the screen. Now, if you saw that the application that was exploited quickly turned red here, because now at runtime, we have detected that somebody exploited it. I can even go drill down into the application and see what really happened. If you notice here, there were many containers that were running for this unprotected application, and one of them was exploited. If you notice, all of these are running in reveal mode, so no blocking is happening, but at least I'm able to observe what's happening across the attacker, across the application, across the various callouts. Now, if you notice here, we detected a payload interception, and you'll be able to see what the payload is in a second, and you'll be able to see what the attack was. So here so happens that since we're looking at the data flow that's happening, we are able to identify a JNDI attack on the application, wherein the user injected the JNDI control to exploit the application. So this is how Reveal can look at all the application data flows and also identify threats in terms of injection attacks, etc., depending upon all the policies that have been enabled on those applications. So now that you've seen how we are able to observe into that unprotected application, I also want to be able to show you how will that architecture model for that unprotected application look like. Here's how the unprotected application will look like. If you notice, the unknown client, which is my browser, came into that unprotected Log4j application, exploited the JNDI, and then made outbound calls to the attacker terminal and also to the LDAP, which happens to be running on 1389. And then also the injection happened through the port 8000. And also the attacker now called out the remote shell to 9001 and now got the full control. You'll also be able to see that not only I got in, I was able to download wget, which is highlighted here. Also at the same time, when I downloaded wget, I was able to go to Google, and you see that connection going to Google is also captured. And all the flows pertaining to all the applications that were downloaded or executed in that environment all get injected with the plugin, and the plugin is able to immediately start collecting telemetry for these applications. This is how Avocado's observability works providing you detailed flow in terms of all the threads that are coming in, all the flows that are happening, and the architecture model, a runtime architecture model on the fan out of your application at runtime. Also, if you notice here, you'll be able to click on these applications and see all the vulnerabilities that were exploited. In this case, if you notice, the Log4J vulnerability was exploited and clearly shows how the exploit was identified and reported back to the orchestrator from an observability perspective. Okay. Now that you've seen Avocado in action with Reveal, I want to be able to show you how now I can protect the same application from any of these injection attacks. So I have the same application running in a protect mode with of Avocado. So here, this happens to be an application that's running and exposing a specific port from communication, which is port 8080, which is what I'll be accessing part of this step. Now, let me switch to the protected application. Now, as you see, I'm going to restart the reverse shell. As you see, now I'm going to go ahead and inject the JNDI string into this protected application. First thing you would see is, hey, the attacker was never even able to get outside and even contact the LDAP server. And the attacker's terminal never even got a connection. Everything was blocked internally in Avocado and never let things go out. Now you'll be wondering, hey, if I did have a policy allowing a general LDAP connection on a port 8080, what would happen? So if you notice here, I'll go back to the policy management screens in Avocado. You see I disabled the fake LDAP access. Let me go ahead and enable the LDAP access. Now, as you can see, the policy has been scheduled. Now the LDAP connection is allowed to go through. Now you'll see I'll do the same injection command. And try to log in. If you notice now, the LDAP connection came through, but the rest of the flow was blocked. So now the zero trust is acting such a way that any flow that's happening here is inspected carefully, verified for trust, and then allowed to go through or not. In this case, since we created an exception for for the LDAP connection, it allowed that to go through, but it did not allow the other connections to go through and preventing the attacker from getting control over the environment. This is how deep Avocado goes in, looking at every flow that's happening in real time. Remember, this is all happening in real time, and taking action based upon what it is observing in real time. This is the power of Avocado. With that said, what I'm going to do is stop and provide you a few minutes to ask me any questions. Any questions? So one of the common questions that we get asked by many of our customers is, hey, today there's a lot of these technologies out there. We have network firewalls. We have microsegmentation available. We have SIMs, which are collecting all of these threat intelligence. All of them provide us a way to prevent threats and mitigate threats. So this is a common question we get asked. And the question also points out one important thing. Most of these tools that I talked about, whether it is firewalls or microsegmentation, is purely looking at from a network traffic perspective. This network traffic is good, and it's for many times it's good enough. But what happens when there is a zero-day attack? How will you prevent something like that from happening? Also, one of the key things that's lacking in most of the existing technologies is the lack of context. They don't understand the context in which the attacker is exploiting a given application. Since we are close to that application, we're able to identify those threats in the context of the application and prevent that from happening within the application. There might also be a discussion around, hey, the SIMs also collect all this data through logs and various other sources. Can't we use that to provide the same level of functionality? Why is yours so different? Well, one thing I mentioned earlier, all of these attacks that are happening in real time, and Avocado is protecting, observing, and blocking them in real time. This is a fundamental difference with SIM logs and log processing that's happened, which potentially sometimes takes even days before the attack was detected and any mitigation can be done. So we are at that juncture of the attack wherein we see and identify threats at the scene of the crime and block it at the scene of the crime. So this is how Avocado works. Excellent question. I think there's a question on from one of the viewers about what technology do you use to block zero-day attacks without signatures. One of the key things that Avocado has built out part of our IP is the ability to work without signatures. When you have a attack like a zero-day attack without signatures, what we do is we provide within the application, within every connection that's happening, a small machine learning algorithm that detects and learns the zero trust nature of the application. So every data exchange that is happening between application is goes through a verification step and a trust verification step, wherein we look at the flows on a multidimensional context and then enforce the trust on those applications. Because it's zero trust in nature, everything that we treat is untrusted unless it passes our signature validation and trust verification. That's how we kind of enable zero trust without signatures, because that is our way of operating within the application and preventing threats from moving laterally. Any more questions? All right, we have a few more minutes. Very good question. I see somebody asking, if I have a WAF, do I need Avocado solution? Absolutely. Avocado solution works in conjunction with other security technologies, right? Remember, we're talking about defense in depth. When you have defense in depth, the many layers of protection that you have is better. And the key advantage of Avocado solution is that WAF protects most of the application processes, particularly the web applications, at the perimeter level. But what happens if the threat has already landed it? And what happens if the threat is moving from application to application? Our focus, again, from an Avocado perspective, is that east-west lateral movement of the threat. Obviously, if something that bypassed the WAF because the lack of signature or some other means, if it gets in, we are able to prevent that from happening. So that's why we kind of complement WAF technologies, but extend some of the WAF technologies to the east-west portion and at the application on the process level. Okay. I think the same question is being asked: what technology you use to block zero-day attacks without signatures? I think there was another question about the same. Um, Oh, sorry. The questions are coming from the top. How long does it take the Avocado to implement the solution for a vulnerability identified today? Very good question. So Avocado's method of operation, again, because of the way the zero-day attacks and vulnerabilities out there, is to provide that protection very seamlessly without even modifying your applications. So if there is a vulnerability and you want to block it then and there, we provide the ability to create that policy. If it is a data policy, like preventing a CRS attack or a SQL injection attack or any other custom attacks that you have, you can create those policies on the fly using the policy manager screen, using the data policies here for that matter, and then you can target it towards a specific application. So this can be done in real time. You don't have to modify your applications to make that work. Also, if you're talking about other vulnerabilities out there, you can customize some of these rules and policies specifically for your application and then implement it specific to the application. Unlike a WAF where you're applying it across the whole network, here you can target it to specific applications. There's one more question out there. Um, do you have any plans to extend your tools into industrial control systems or OT networks? There are some future plans from an Avocado product perspective to expand into control systems and OT, particularly in the energy sector. We've had many customers in the energy industry ask about it. So we are looking at that as a part of our roadmap once we get past the initial set of applications and deployments, and that'll be our future towards IoT devices, etc. There's another question from another viewer. How long does it take Avocado to implement the solution for a vulnerability identified today? Immediate, 1 day, or 2 day? Again, it all goes with how quickly do you want to react to that solution. Since most of the tools here are managed through the orchestrator, creating policies and applying policies can be done instantaneously as soon as you have the policies defined. So depending upon the scale of your deployment, you could create automation using CI/CD to apply it at scale. Or if you're simply targeting a single application and want to protect it, you can just come to the orchestrator and do it online. Right? Any more questions? All right. If there are no further questions, I would thank you all for taking time in an afternoon today to come and listen to this webinar, and appreciate any feedback or anything from, if you're interested in understanding more about the product, we would be glad to connect with you and provide you details, and I could discuss further. With that, I'm going to end the talk.